guys, in the last video, we got a clear overview of what statistics is. Moreover, we saw that the collection of data is done in two ways. One is the primary collection of data and the other is the secondary collection of data. Now, as soon as the work related to collection of data is done, the next step is to present the data in a proper form so that it is easily understood and one can point out its main features in just one look. So, let's go down the memory lane and recall some of the ways of presenting data through some examples. The basic unit of statistics is data. But do you remember what exactly data is? Well, the word data means facts or figures which are collected with a definite purpose. It is mostly numerical. So let's move forward and consider the marks scored by a class of 10 students in a maths test. You already know that data obtained in this form is called raw data. Basically, the data obtained in the original form which has not been processed or converted in any other form is called raw data. Now, we want to know who scored the highest and who scored the lowest in the maths test. Did it take you some time to search for the maximum and minimum scores? Wouldn't it be easy if these scores were arranged in ascending or descending order? So let us arrange the scores in ascending and descending orders and then choose the relevant observations. Now we can clearly see that the lowest mark is 25 and the highest mark is 95. You can either arrange the data in ascending order or in descending order. It is up to you guys. Choose whatever suits you. One important thing to note is that the difference between the highest and the lowest values in a data is called the range of the data. So here the range is 95 minus 25, which is 70. So the range is 70. But we know that the presentation of data in ascending or descending order can be time consuming and is not always favorable, particularly when the number of observations in an experiment is large. For instance, consider the marks obtained by 40 students in a class. Now, how many students scored 4? Not possible to find in just one glance, right? But I hope you remember that we learned to organize this type of data in tabular form using telemarks. Like this. Now it is clear that 7 students scored 4 marks. I hope you remember how to use telemarks. Keep marking the consecutive lines for the first 4 observations of the same entry. Then cut them diagonally for the 5th observation. Continue the same way till the last observation for all the entries. Now it is clear that the number of tallies for each score gives the number of students who scored that much. This is known as the frequency of that particular score. Frequency is just the number of times a particular entry occurs. So, the frequency of students who scored 8 is 4, the frequency of those who scored 7 is 5, and so on. Such a table is known as ungrouped frequency distribution table because here all the entries are single and not in groups. Moreover, we already know that adding all the frequencies gives the total number of observations of the dataset. So here, total number of observations is 40, which is true. Great. But sometimes we may have a large variety of data which wouldn't provide as much information as we just saw even if we tabulate it using the ungrouped frequency distribution table. For instance, consider the marks when we asked the class of 60 students their score in mathematics text, which was out of 50. Now, there are too many unique entries unlike the last data set where there were only 9. So you can only imagine how many rows there will be for this data set. This is where grouping data comes in and saves the day. You already know this, right? We make equally sized groups of observations, say 0 to 10, 10 to 20 and so on, and obtain a frequency distribution table like this. Data presented in this manner is said to be grouped and the frequency distribution table so obtained is called grouped frequency distribution table. Now we can clearly see that 21 is the highest frequency, which means most of the students scored marks between 20 and 30. Also, there are 2 plus 10, that is 12 students who scored marks less than 20. So, it's quite evident that grouping data in this form helps in obtaining important information where the data sets are large and have too many unique entries. Now, each of these groups like 0 to 10, 10 to 20, 20 to 30 and so on is called a class interval or simply a class. In these classes, the lower numbers are called lower class limit and the upper numbers are called upper class limit. For example, in class 10 to 20, 10 is the lower class limit or simply the lower limit and 20 is the upper class limit or simply the upper limit. Also, the frequency corresponding to each class is called the class frequency. Hey, do you know what class size is? Well, the difference of the upper class limit and the lower class limit is called the class size or class width, which is 10 in this case because 10 minus 0 is 10, 20 minus 10 is 10 and so on. In a group data, the class size is the same for every class because remember, we take equally sized groups or classes. Now, there is a very important thing to note about class intervals. We can see that some numbers occur in 2 classes, like 10. It occurs in class interval 0 to 10 and also in class interval 10 to 20. So, if a child scored 10 marks, under which class shall we record it? Yes, you said it right. We will record it under the higher class, which is 10 to 20. Similarly, the observation 20 will be recorded under the higher class, which is 20 to 30 and not 10 to 20. So, in a class interval, the lower limit is included in the class while the upper limit is not. So this is all for today, guys. I hope you had a nice time knowing how differently data can be presented. Now it's time for me to leave. So let's have a quick recap. The word data means facts or figures which are collected with a definite purpose. It is mostly numerical. Data obtained in the original form is called raw data. The difference between the highest and the lowest values in a data is called the range of the data. Adding all the frequencies gives the total number of observations in the dataset. A table containing the frequencies of all the unique entries of a dataset is called an ungrouped frequency distribution table. The number of observations falling in a particular class is called class frequency. Large datasets with a lot of unique entries are tabulated using equally sized groups called class intervals. This results in grouped data, and the frequency distribution table so obtained is called grouped frequency distribution table. In a class interval, the lower number is called the lower class limit and the upper number is called the upper class limit. For example, in the class interval 10 to 20, 10 is called the lower class limit and 20 is called the upper class limit. The difference between the upper class limit and the lower class limit is called the class size or the class width. It is same for all the classes in a grouped distribution.